Hi guys, this is the final unit on trigonometry. There'll be a quiz on it later this week. We are looking at how sinusoidal functions apply to real life situations. So things like sound intensity, light intensity, tides as they come in and out, and the height of the water and how that changes, and it's periodic because it continues to do the same changes every single day. The height you are on a Ferris wheel compared to time as it rotates around, and pendulums and springs and how they differ in height through time. So anything that's periodic can be modeled with some sort of sine or cosine graph. We're going to do an example with a Ferris wheel. So it's always good to draw your example first. This one's drawn for us first, but we're going to take the key information and make a sinusoidal function out of it as well. So a Ferris wheel has a radius of 45. Let's just put that somewhere on this Ferris wheel, maybe right here. So that is 45 meters. And it's centered 50 meters above the ground. So that means from here down to the ground is a full 50 meters. So it's a little bit higher than the radius of 45 because we need the wheel to be a little bit off the ground, right? So let's do a different color. If this were 45, the other part of the radius from the center to the bottom of the wheel, then the wheel would have to be just a little bit further above the ground so that this person wasn't scraping the ground on their way through, right? And it tells us it takes one complete rotation to make one complete rotation takes 20 seconds. So what we're going to do is we're going to kind of graph what we know so far. So we're going to have height on the y-axis, time on the x-axis, and we know it takes a full 20 seconds to complete a rotation. We're just going to graph one rotation. And if it takes a full 20 seconds to do one rotation, then that means at 10 seconds, you would be halfway through the ride. And then we can label the 5-second mark and the 15-second mark. It doesn't have to be perfect, just as long as it's somewhat spaced out evenly, which this one's not really, but that's okay. So they're going to get on the ride at this bottom cart. Well, if the Ferris wheel has a radius of 45 and the center axle is 50 meters above the ground, then they're actually getting on at a height of 5. And since it takes 20 seconds to completely finish that rotation, that means they're back at a height of 5 at 20 seconds. So as they go around this wheel, at 20 seconds, their height is 0 again. Or not 0, sorry, their height is 5. If we follow this rotation around to the 10-second mark, they should be at their max, which in this case would be the 50, which is the center axle, plus an additional radius of 45. So 50 plus 45, their max is going to be at 95. And that's going to be at 10 seconds. Okay, let's look at the 5-second mark. By the 5-second mark, they should be a quarter of the way through, which is right here. So they'll be at a height of 50 because that's the center axle. And so again, we get on at 0. This is 5 seconds. This is 10 seconds. At 15 seconds, they're back to that height of 50. And at 20 seconds, they were back to the bottom. Okay, and again, this is considering that the wheel is going at a constant speed, and basically from the moment they get on that bottom cart, they are traveling at a consistent speed throughout. So we have this function. Okay, again, my graph's not quite perfect because my scale is too spaced out between 0 and 10 compared to 10 and 20. But it is a cosine graph. It's inverted. Remember that a normal cosine graph is at its max first and then back up to its max. This one is an upside down cosine graph. It's starting at its min and coming back to its minimum. All right, so some important information we need to figure out. We're going to choose to do a cos graph because of the fact that this is just an inverted cos graph. And we're going to solve for A, K, D, and C just like we did in the non-word problem examples last week. So amplitude. Actually, let's not start with amplitude. Let's start with axis of the curve, which is your C value. Remember, it's max plus min divided by 2. So we're doing 95 plus 5 divided by 2. And 95 plus 5 is 100. 100 divided by 2 is 50. The other way that you know it's 50 is because of where the center of the axis of the wheel is. 50 is the very center that this person's going to be. So sometimes they're above 50, sometimes they're below 50, but 50 is the middle. And that is your axis of the curve. Again, this isn't quite perfect, but there's your axis points. All right, so axis of the curve is 50. And then amplitude is how high the person travels above and below that axis. So the amplitude, because they go up an additional 45 meters, because the radius of the wheel, and they go down an additional 45 meters, your amplitude is 45. All right. What else do we need? We need the K value. K is calculated from the period. Period equals 360 divided by K. It gave us in the question that it took 20 seconds to do a full rotation. And we did the sketch, and we do have a full inverted cos graph from 0 to 20 seconds. So 20 goes in for a period, equals 360 divided by K. Bring K up, you get 20K equals 360. Divide out your 20. 360 divided by 20 is 180. No, sorry, 18. The zeros cancel, so you get 36 divided by 2. So your K value is 18. And now, because we chose to use a completely inverted cos graph, there's actually no shift left or right. So you could see from my normal cos graph here, if I were to just reflect this, where the max becomes the min, and the min becomes the max, this is going to be the same shape as we have in the cos Ferris wheel graph. So there's no shift left or right. That makes things easier. Because of the fact that we have to reflect it, we have to make sure we put a negative in front of the amplitude. The amplitude itself is never negative. The negative is just in front of the amplitude to reflect it. Okay, you technically can't have a negative amplitude. So we've got negative 45 cos of 18x, and actually I'm going to change that in a second. I want to use t for time. Let's turn this into a little bit more of a function. Remember, this is the height of the rider at a certain time equals negative 45 cos of 18 time plus 50, where t is the time in seconds and h is the time in meters. So there is your equation. Okay, let's put that over on Desmos just to make sure that it makes sense. So we've got negative 45 cos of 18, Desmos uses x, and we added 50 for the axis of the curve. This is going to look really crazy. It looks like they're doing a whole bunch of rotations on this on this wheel, but it's because we're not in degrees. We have to change to degree mode, and there we have our rotation. So there's the rider getting on at a height of 5. Here's the rider at its maximum height at 10 seconds and maximum height of 95. And then over here, the rider is back down to the minimum height of 5 as the wheel finished the 1 rotation. So our equation matches perfectly with the description of that question. Okay, part B. How high is the rider after 17 seconds? Well, let's have a look at the graph. 17 seconds is about here. And we can see the rider is somewhere between the 5 and 50 in terms of height. How can we calculate that exactly? Well, since they're giving us the seconds, all we have to do is sub 17 in for time. So we're going to find h at 17. When you're putting in 17 here, you want to make sure you're doing cos of 18 times 17. So you're making sure you do the cos of the entire 18 times the 17. On your calculator, you can do negative 45 cos, put in the bracket here, make sure you're multiplying 18 by 17, close the bracket, and add 50 to the whole thing. And the rider is at a height of 23.5 meters at 17 seconds. Okay, and we'll pop back over to Desmos and we will double check it when we put x equals 17 because that's time. So it's putting an imaginary line at 17 seconds. It's going up and identifying where that is, and there it is at 23.55 for the height. Okay, and then the last part of this word problem. Between 0 and 20 seconds, when is the rider exactly 30 meters off the ground? So this middle axis was at 50. This was at 5. We want to know when the rider was exactly 30 meters off the ground, which would be about here. So our goal is to find these two answers. There will be 2 times the rider's at a height of 30 because he's going to be at a height of 30 on his way up from his original position of the wheel and when he's back on his way back down. So we have to find those 2 points. Because this is height, we're going to sub this in for h and we're going to solve for t. I'll just rewrite the equation. So that was the equation. We're going to take 30. Because it's height, we're going to sub it in for the entire h at t, so the entire left side. Now, this is our first time solving trig equations. It's more of something you do in grade 12, so you will see this a lot next year, but it's a little bit incorporated into word problems in grade 11. So what we want to do is get 18t by itself. We have to do the opposite operations to get rid of things. So the first thing we're going to want to get rid of is the positive 50. Bring it over and subtract 50. You get negative 20. So imagine this is like having a negative 45x. If you had just a negative 45x, you'd want to divide both sides by negative 45 to clear it out. So 20 divided by negative 45. And on the left side, we're left with cos 8, on the right side, we're left with cos 18t. So 20 divided by 45, the negatives cancel out and you're left with 4/9 here. So all I did was divide this. And then this side, these canceled, and then we're left with cos 18t. Remember that this is still an angle. Anytime you are solving for something with a sine or cos attached to it, you're really solving for an angle. So what we want to do here is we want to do the cos inverse of 4/9 to cancel out cos. So basically we're bringing cos to the other side. And that's going to leave not just theta or x, but it's going to leave the full 18t still. So basically what we did was we isolated this as if this was an entire angle. So cos inverse of 4/9 is 63.6. And then we still have the 18 in front, so we're going to divide both sides by 18 now. And you get 3.5. So this rider is at a height of 30 at 3.5 seconds. All right, that's not quite the only answer. Remember, we talked about the fact that there's going to be a second answer. So this was 3.5 seconds from time 0. Remember at time 20 seconds, they were back to 0. And sinusoidal functions, cosine and sine functions are always symmetrical. So if it took 3.5 seconds to get to that height of 30, then it's also going to be at a height of 30 3.5 seconds before 20. So what we have to do is we have to minus 3.5 seconds off of 20 and get back to where this was, which would be 16.5 seconds. So the rider's at a height of 30 meters at 3.5 seconds. Sorry, it keeps jumping on me. And at 16.5 seconds. Those are the two times where the rider hits a height of 30. And that was just completely from symmetry, knowing if you have to go over 3.5 seconds from 0, then you have to go back 3.5 seconds from 20, because 20 was when the rider was back on the low point. And we're going to check that on Desmos as well. So the height was 30, so we're going to put in a y value of 30. And I want to make that dotted. We can take out the x value of 17 now. And we can see our two answers, 3.5 seconds, and again at 16.46, which is 16.5 seconds. All right. And if we wanted to put in the axis of the curve, we could change this to 50. Remember, this was the very center of the graph. We can see that there's an equal distance from this axis of the curve to the max and from the axis of the curve to the min. And then whatever height you want to find, you can just basically put in Desmos. So if you wanted to know when they're at a height of 90, we could just change this to 90. We'd find the two times when the rider hits a height of 90. And that's very close to the top of the wheel, because remember the top of the wheel was 95. So if the top of the wheel is 95, they're going to hit 90 just before the top, and then as they come down, they're going to go through 90 again. Okay, by all means, use Desmos to help you with trig functions. And the sketching of a graph is so important. So when you first read a question, identify what you're comparing. So this was comparing height to time. So I set up height on the y-axis, time on the x-axis, and then I started to put in key points that were given in the question. Okay, so it's just a matter of taking the information in the question and making a sketch out of it. As soon as you have the sketch, you should be able to do A, K, D, and C and solve for some of those parameters. All right, I will post the homework. The homework, I think, is 6 questions. They're all word problems. And then the test will be posted on Wednesday this week. And then the culminating will also be posted sometime this week. All right, have a good day, guys.